Welcome to this installation video and demo of the OSR4Rights FaceSearch tool. The first thing you want to do is to download Docker for your appropriate host operating system. So if you go to the docker.com/products/Docker desktop site, you can find there different versions for different operating systems. We're going to go for the Windows one because this is a Windows machine, and recommend going for the stable version and then download that and go through the usual installation process. I've already done that on this machine to save time, and now in the system tray I can find this little Docker icon. If I left click on that and go to the dashboard, it will now show me that the service is running, but I have no containers yet. I can see the service is running because down here I have a green status light and it tells me the service is running. That can take 5 to 10 minutes the first time you install Docker, so don't be alarmed if it takes that long before the green status light shows. But you can't continue on to the next stage until that green status light is showing. So I'm just going to minimize that for a second, and we're now going to look at how you install the Docker image. So installing the Docker image means pulling a copy of the code that the OSR4Rights team have written onto your local machine. This is done through a command prompt. So on a Windows machine we can press the Windows key and R to bring up a command tool and type into it cmd. Hit return, that brings up the command window. We can also do this from the start menu, so type start menu, open the start menu and type in command, and you can see there command prompt, which will do the same thing. We only need one of these windows open, so I'll shut this one down. Now into this you type the following command: docker pull space geospatial /OSR4Rights _ FaceSearch. That's documented in step 2 of part A of the installation guide. Now again, I've already done this on this machine to save time, but I'll press return and see what happens. It's going to go and check against that repository, and it says here that the image on this machine is up to date. So therefore we have the latest version, it doesn't need to download anything. On your machine, if this is the first time you've done this, it will take several moments, depending on how fast your internet is, to download that Docker image. The next thing we're going to do is create a folder on the host PC where we're going to store the images we wish to scan. So I'm just going to go to Windows Explorer, and here I've created already a folder in the C drive in a subfolder called Data and another subfolder called Images. Now this is a folder which will be shared with our Docker container, and it's important to make this path as simple as possible, so don't include spaces and funny characters. So ideally if you could copy this, C data images, that would be perfect. Also note that this could be on a different drive letter, something like a network drive or a plug-in USB hard drive would be fine, as long as the drive letter you use is the same every time you want to run this tool. The next step in the installation guide goes through how you would then allow Docker to access this folder. Now there's been an update to Windows where they've included something called the Windows Linux subsystem, which now means you don't need to do that step if you're using a very up-to-date version of Windows 10. So the next step I'm going to skip because this machine is running the very latest version of Windows 10. And I'm going to go into step 5, setting up a container from the Docker image. For this we go back to the command window and we run a command which will use that Docker image we've downloaded and make a container from it. So this is only ever done one time on each machine. Docker run -p space 5050:5050. So that's the port that we're going to expose. So effectively Docker is going to act like a little web service, but just on your network or on this machine, depending on how you have your Windows firewall set up. -d, background daemons, it means it will keep running, and then we're going to map that volume. So -v is the volume we want to map. So this is C:\data images that I just showed you I created in Microsoft's Windows Explorer. The thing to note here is that these are forward slashes rather than backward slashes, and that's because we're working with a Linux subsystem underneath. :/data, so that's how the Docker container will see this file, this folders. It will see it as a data folder, but actually it's mapping to your host machine as C data images. And then you can give it a name, so --name, and this could be anything you want. I recommend just keeping it simple. Let's call it what the tool is, so OSR4Rights FaceSearch. and now we tell it which actual Docker image we want to use. So that's geospatial / OSR4Rights _FaceSearch. That's one we downloaded in the previous step. And now we tell it which command we want it to run when this container is spun up. So we want it to run a command called facesearch.sh. So I'll hit return. It now returns us this long string of letters and numbers. Don't worry about that. That's just a unique code that can be used to identify that particular Docker container. If we go back to our Docker, which we can get from here from this tool, and then right click and go to dashboard, we should now see that there's actually a container running. So you remember earlier on we were told there were no containers. Now it tells us there's a Docker container running on port 5050. And we have various commands here, so we can stop that if we wish. We can restart it if we have some kind of issue like it crashes. We can go to a command line, which will actually let us see the Linux system that's running inside that Docker container. We'll come back to that in a second. And we can delete it if we want to get rid of it completely. We can also click on this button to open in a browser, and because we're running on port 5050, we'll now open up the local host on port 5050, and you should now see something like this. So this is the OSR4Rights landing page of this Docker container. I'm just going to shut that down for a second. This here is the Linux subsystem. I'm going to show you what we've got. If I type ls, which means list, you see there's a folder there called data. If I go cd data to change directory to that and have a list, there's nothing in it at the moment. But that, just to show you, is mapping to the C data images that we had created here. So I'm now going to create a subfolder in here just called OSR4Rights. You do need to have this folder. It's pre-programmed to look for this folder, so OSR4Rights. And inside of that one I'm going to create two more folders. Again, you need to do this on your machine. One is going to be called search and the other will be called target. So this is just checking with the installation guide is the bit on part B, step 2. Okay, for now leaving those empty, but I'm going to go back to this, which, as you remember earlier on, is empty. If I type ls again, you now see it has a subfolder OSR4Rights. So this is just looking at the Linux container running inside of Docker, and it's able to map through the data folder as it sees it to whatever path we have on our host machine. This is literally the only place it can see on your host machine. So if I now do in my Docker container cd OSR4Rights and then list there, we should now see we've got the search and the target, and they're currently empty. I'm going to exit that. We didn't need that. You don't need to do that bit. That's just to show you actually what's going on in the background. Okay, I've just gone and grabbed some images from the internet, and I'm going to use those as demo images to search for faces. So I'm going to go into OSR4Rights on my Windows machine, into the search folder, and I'm going to paste a copy of all the images I've downloaded. So we've got some pictures of Burt Reynolds, BR 1, 2, 3 and 4, some group pictures of friends of FR1 and FR2, some pictures of Jennifer Aniston, JA1, JA2, and some pictures of Matt LeBlanc, MLB1 and MLB2. I'm now going to pick one to search for. Let's pick the first one, Burt Reynolds, and I want to put the copy of this, in this case, into my target folder. I'm now going to go to a web page and have a look at what we see there. So we could do this two ways. We could use this button here to open a browser, or just to show you, you can just type this into your favorite browser. Recommended Chrome, because of some of the technologies we use. You can use Edge as well, but it must be a very, very up-to-date version. And you can type in here 127.0.0.1:5050, which is the same as the local host. This now is the landing page for the Docker container that's running on your machine. If I go to check files, I should see here a list of those files which have been shared in that folder. So we had BR1 for Burt Reynolds, BR2, BR3, BR4. It doesn't list all of them, it just shows you the first few to make sure you're looking at the right folder. But it does tell you here that there are 10 images in total in that folder. It does the same thing for the target images, and here we can see there's 1 in total. Currently we don't have any of these things, HOG or CNN files, and that's what we're going to create next. So the way face searching works is, first of all, you have to encode the image by looking for faces. When you find a face, you then encode it into an array of numbers, and then we can finally compare those arrays of numbers to see if there are any matches. So we're going to do the fast encoding first of all. This will take a little while to run, depending on how fast your machine is and how many files it has to go through. Okay, so that's finished on this machine now, and it returns a list of image details, which is this item up here, this icon. And it says for the hog method, which is the fast method, that for these particular images, how many faces it found. So we can see that these ones here have all found one face, and these two at the end here have found 6 faces. And these ones you notice are the FR1 and FR2, so the friends group. So that makes sense. And just to compare back to the original image, if you go back to the search folder and have a look, we see that each of the images is still there, and alongside them it's created this extra file with the same file name but a different extension, so it's .fe_hog. So this is the face encoding file using the hog method. These are extra set of files which when we do the actual searching, it will compare these rather than looking at the images. So these should be kept with these images if you want to be able to do face encodings. We use this set of face encodings in the future. And just to have a look at that the face group picture. So this was 1, 2, 3, 4, 5, 6, and that's what we found. And the other group picture, if I can find it on this machine somewhere. One, 2, 3, 4, 5, 6. So it correctly managed to find all of those. Now remember that our test picture was a picture of Burt Reynolds, and if I go to run search now, I've only got the option for the first fast hog search because I haven't created yet any CNN encoding files. We'll come back to that in a second. So let's see what happens if I push this. So this is the picture we searched for, the target we're looking for. We look through the folder and these are the matches. So we've managed to find 3 pictures of Burt Reynolds, even ones where he doesn't have a moustache. The numbers reported here are how close the matches are. Now this is an exponential kind of numeric system, so anything with sort of 0 to 0.15 is a very good match, up to 0.35 is a very likely match, up to 0.55 is still a possible match, but beyond that it's unlikely, although there may be some sort of similarities. So basically anything up to the sort of 0.5s we're definitely going to have a good look at and verify if we think it's true. So these ones have got 0.2, 0.3 and 0.4, so it's basically telling us that these seem to be pretty good matches. If you want to see any of these pictures in more detail, you can just click on it and it will take you to the original image. So if you want to compare these at a larger size, you can go and do that. Okay, if I want to now add to my search, so if I look at my files again, I've only got one target image. I can add another one, so let's just try taking a picture of say Jennifer Aniston, copy that and put a copy of that one into my target folder, so we can have multiple images in our target folder. That's absolutely fine. Now when I go here again, it wouldn't find it until I've actually created the corresponding encoding file. So I'm just going to run that. That's going to be quite a bit quicker because it's only got to build it for the image in the target area. In this particular case, it's already actually built it in the search folder. I could have copied it across, but just to illustrate the point, it will generate just for the missing ones. It doesn't need to rebuild for the ones that already exist. So that's now finished. Now if I run my search again and go to hog, first we get the Burt Reynolds matches, and then underneath that there's a picture of Jennifer Aniston and the matches here. So this one's not quite so good at 0.43, but it's still within kind of a tolerance be considered good. It's got the group match, and then it's found the other individual picture of 0.46. So they're all less than 0.5, so therefore all considered pretty good matches. So it's managed to find her even in the group shots. Okay, next up we're going to look at the CNN method. So if we go back to check files again and have a look, it tells us here that we've built 10 hog face encodings, but we've not yet built any CNN ones. There's still 0 showing here. So I'm now going to run the detailed version. This is going to take quite a long time. It does benefit from using GPU, but that requires quite a lot of work to compile source code on your particular machine. So this is using the CPU, and it's considerably longer to process. However, it does have the advantage of being able to spot faces that are not directly looking at the camera, more side-on faces and so on. Okay, so the CNN encodings have now finished. We have the same kind of results as before in this particular case, so 1 face found in these images and 6 in the last 2. That may not always be the case depending on how obscure those faces are and if they're not looking at the camera, etc. But now let's go and run the search, and now because we do have these 10 source encoding CNN faces and 2 target faces, with the CNN method I can now have the CNN button option instead. So these are the results. The Burt Reynolds image has come back with the same set of images. I think these figures here, the actual face match values are slightly different. If we go down to the Jennifer Aniston one, again we've got the first image, but then after that you notice it's not showing us pictures anymore, but just saying here's an image link. That's because I've set it up so that if this value is greater than 0.5, we're less confident this is a good match. Instead of taking time to bring in all the photographs to this web page, potentially with maybe hundreds or thousands of photographs you scan through, take a long time to load the page, here it just brings an image link you can click on and then it will show you the picture. It just makes things a little bit faster. So there again, it has found all the right people from our collection, but in this particular case the CNN method was less confident that this photograph matched these two here. And that's one of the things to bear in mind when using face searches. It can produce false positives and false negatives. I just want to point out another thing. In the About section here, there are a couple of options. So the first one is you can turn the small faces search on or off. This won't make any difference once you've already encoded the files. It's just something to bear in mind before you do the encoding for the CNN version only. The CNN one, to remind you, is this detailed version of the encoding. The reason being that that is actually quite slow to run, but we can speed up the process by just looking at an overview of the picture rather than zooming into it many times. So if all your pictures have faces which are fairly large in the image, you could turn this off and see how that goes, and that'll tell you that it's off, and now you'd run the encoding in the detailed version. So just to confirm, this makes no difference at all to the fast version. It doesn't rebuild the file, so if I were to click this now, it would be done in an instant because the file's already been built with the small faces on setting. So it doesn't make any sense to rerun it with the small faces off after you already run it with it on. But if I had done it the other way around and run it off and then not found many faces, as confirmed by this image details, this would return lots of zeros when I knew there were faces in it. You may want to come into About, turn the small faces setting on, and then you'd need to delete all of the existing CNN files. So if you type this in here, delete CNN, okay, you now see all the CNNs have been set back to 0. So that's actually gone into the folder on your host machine here, and we're left with the hog files but not the CNN files, so it's delete all those. I could also delete all the hog files here if I want to tidy up my disk for whatever reason. The final thing I want to point out is in the check files, there is a little procedure here where if you've moved your files around and you're not sure if the hog file or CNN face encoding file matches the image you've got there, you can push this button and it will do a check. And the way it does that is it looks at the image and builds a hash code for it, and it checks the encoding file and the hash code that was saved with it to see if the same hash code exists. So here it's checked the 10 images in the search folder and no issues have been found. I'm just going to go and change one to see what happens. So if I was to go into my search folder, it only checks the search folder, by the way, and load one of these images into a paint shop package. I should use this one. So I'm just going to attempt to get this Burt Reynolds picture in here. I'm just going to doodle on it a bit and save that. Close this. Go back in here and do the check again. It says issues have been found, so it tells me now that this image br1.jpg, the image file doesn't match what was encoded last time we did an encoding. Okay, so this is just helpful if you think perhaps you have a bunch of files with very similar names and somehow maybe the backup version you have has got mixed up hog files, etc. Okay, I think that's about all. So thanks for watching, and hopefully you might find this tool useful. Bye.